This is the same sort of technology that's in, like, if you get solar panels on your roof, it's the same thing that's inside the Tesla Powerwall. But basically, it lets you turn the battery energy into grid energy effectively. The idea is basically battery energy that you're not using to cook your meals, you could push into your house to run other appliances or your laptop or whatever, to instead of grabbing new energy from the grid at that time that would be more expensive. So you can actually use it as like almost like an energy trading desk kind of thing.
Welcome to the Curiosity Podcast, where we go deep on a wide variety of technical topics with the smartest leaders in the world. I'm Imamd and co-founder and CEO of Mercury.
And I'm Raj Suri, co-founder of Lima, Presto, and Lyft. And today we're talking to Sam D'Amico, who is the founder of Impulse Labs, which makes smart appliances to help. It's a cooktop that basically is much more powerful than existing gas and induction stoves. I believe it's at least 3 times as powerful as induction stoves and 5 times as powerful as gas stoves. And he's innovated on a much more powerful technology that can, I believe, boil water much faster and cook anything faster, so people have to wait less time. Very interesting technology, and Sam's a really high energy guy and very persuasive when it comes to talking about his, how much better his technology is, and overall very impressive. Imad, what were you curious to learn about from Sam?
Like, often when you see these gadgets, they're quite shallow. It feels like something you could copy easily. It doesn't have like I do agree with like smart appliances. It feels like they're very gimmicky. What I thought was really cool is like, it definitely has like feelings of Tesla, right? Like it's like high performance, but it's also got the practical kind of, it's going to work when the power's out. It's going to push power to your home through the battery. So it's got these like interesting elements that I think are really powerful. And I don't know if it's got the exact form factor that I could use, but I'm actually kind of excited about trying it out and having it in my house. I think the other thing actually is like houses are like a vanity symbol to some extent, right? Like people buy them and they want to show them off. And having like this kind of unique appliance, I think, is like part of the reason why Nest was so successful. So I think it's really cool innovation.
Yeah, I think in houses, people tend to use the best of what is available in general. Like, I think you don't see too many houses using like 10 or 20-year-old technology because the houses themselves have to last for like 50 to 100 years. I mean, you can buy houses, that are hundreds of years old even today. So it's very rare that a new house will be built or a house will be remodeled with old technology. So there's immediately a market for like new stuff and like the best stuff for houses. And that's why, Nest did well. So I think that's kind of the market that Sam's looking to tap into. And, he's obviously has a technical background. He can go really deep in technology, but he's also thought through like all the elements of his business really well, which is very exciting to see that, of a potentially new type of Nest company, or Ring or something like that kind of sprout up and something that can improve everyone's lives. Cooking things faster is always a pain point. So with that, let's welcome Sam.
Hey, Sam, thanks for joining us.
Hey, great to be on here. Good to meet Raj. I met you. I met you like at some happy hour a couple months ago.
Oh, yes, we did. We met at that Mercury event. It was so cool to see you launch this thing. How long have you been working on it? And give us like a very quick, like, why a stove and how did you get here?
Yeah. So, company was started in 2021 in the summer. I was kind of getting obsessive about kitchen appliances though at my previous job. So I was at the company formerly known as Facebook, working on VR headsets and VR controllers, and like was out in Japan at a haptics conference and got kind of like hooked on this, like there's this pizza place doing like authentic brick oven pizza because apparently Italian food is better in Japan. And I say this as an Italian American. And so I saw my pizza come out in like 30 seconds, 45 seconds. And I'm like, that's crazy high power density. I would be awesome to have a oven like that in my home kitchen indoors. So it'd have to be electric. How could you do that? And I was like thinking about ways to make that work. And this kind of unlocked this idea, which was most home appliances are not being used all that often. They're kind of just sitting there idle. If you can put, let's call it a medium-sized battery in an appliance, you could boost its power a lot. And so then I got really obsessed about making this like tabletop pizza oven with crazy high performance. and then filtered it through kind of the like idea maze of how to make this actually into a startup and all this other stuff, and realized that doing installed appliances, there's been not a lot of innovation in the space in decades. And there's an opportunity to really up level more than just like maybe like make a pizza oven, but like stoves, ovens, water heaters, dryers, etc., could use augmented power from a built-in battery pack. And that was the genesis of what became Impulse.
And this thing that you saw in Japan, that was not battery powered, right? That was
No, this was just an old school wood fired pizza oven. But like the idea was like, could I copy the radiation profile of that with like infrared light bulbs and like pulse it onto my pizza and make it as fast as possible? That was kind of the like genesis story of like, how could I replicate this? Not like I want this exact thing. Wait, we could do something that doesn't currently exist in a tabletop device with this technology angle. And then that's what became Impulse, basically.
I had an induction oven at my previous place, and I just moved recently, and I'm back to nat gas, and I feel like I've stepped like backwards because induction ovens are actually really good. Like I don't think people realize. I think people still think about that as electric kind of heater oven stoves. So I think just the fact that your induction is a big win, but then you have this like big ass battery. Like how big does it look?
It's a 3 kilowatt hour battery, so it's about the width of like, well, my torso. Maybe I should lose some weight, but like you get the idea.
Yeah.
But basically, like kind of maybe shoulder width, and then I think we're about 5 inches thick. Is the battery? So it's
But
like
it
it's
fits
basically
in like
a
a
box.
normal place you would put a stove, right? Like it's not like a different place.
So the way our product works is it's a 30-inch cooktop, and basically you slide the battery into the cooktop, like it's kind of like in the area that goes below the counter. And then it just sits there, just like a slightly thicker stove than normal. That's basically it. And we try to make it thin enough that it clears, like if you have a drawer underneath and stuff like that, you can make stuff work that way. But that's the idea. It's like there's no change in the form factor of the device. Like you put a battery in, it makes the appliance way better. It makes the installation way easier, but like it's the same appliance, the same form factor, fits in the same slot, which is kind of the big part of the big part of this game, basically.
When I got an induction top, I needed a 240 volt connection to it, but you can do it with 120 because of this like battery causing that backup, right?
Yeah. So one thing to think about with this is we make DC appliances. All of our appliances run on DC internally. They just run off the battery voltage. And so before you get to the battery, you can charge the battery at whatever speed you want. Like it's kind of like you could plug in your iPhone to like the bigger power brick or the smaller power brick, and like it'll still charge your phone. You can still use your phone, but like sometimes it might charge faster or slower. This essentially does a couple things. Yes, you can run it off 120. You can also run it off 240. You also could run it in Europe on 230, just the same way as like your laptop works, basically, or your laptop or phone works.
Are people going to end up getting like battery anxiety? Like it's like, oh my God, I can't finish cooking.
Range anxiety. Yeah. So I don't think so. So what's interesting is a normal 120 volt plug gets you like to the stove. It gets you like 1.5 kilowatts or something like that. That is, we actually went and kind of measured what common meals take just to make sure that like, because cooking is energy, not power. Of like, in some sense, it's like, you're not using constant power when you're cooking. You're using like a set amount of energy to like boil the water, like do the chemical reactions, etc. And so it's kind of like a kilowatt hour, which is in San Francisco, maybe it's more expensive, but like you think it's like 50 cents worth of electricity, or 40, 50 cents worth of electricity in San Francisco, and like 15 cents in like places that have more energy abundance. Basically, it's not a lot of energy. And like the battery is a 3 kilowatt hour battery. So you get like 3 meals out of the stove, even if the power is totally out. And then you realize that like on a 120 volt plug, you think like a meal is a kilowatt hour. It might take you 30 minutes to an hour to cook. You will on average be charging the battery while you're using the product, even if you're actively cooking. It's just in those periods where you're like dumping a ton of power in to boil water really fast, or preheating a cast iron pan, or things like that, where you'll actually end up using more power than like what the plug would provide. But generally, you'll end up keeping the battery charged. And we realized that this is actually really interesting because normally when people buy home batteries, they really like care about the capacity. They view it as like this resiliency play. They bought it for like backup purposes. In our case, it's kind of like this exists as a performance augmentation and an install aid, not as like a kind of last ditch like savior for a rainy day kind of thing. And so it means that there's a lot more interesting things we could do with the battery because people are buying it because they're basically getting it for free because they want the best stove, basically, if that makes any sense.
There have been some appliances that have been built, right, over the past 10 years. There's been this wave of smart appliances, right? Like there's been like, I think one of another guy early at Lyft, Matt Van Horn, created this company, June Oven, right, which is like 10 different ways to measure your food, how it's cooked and stuff. What do you think of like the wave of like smart appliances? Has there been something out of there that you think is like really promising? And do you think you're kind of fitting into that category, or you're kind of creating a new category?
I think it's different, but yeah, of course, like I know Matt and I talk to Matt every once in a while. So it's like, it's definitely something where it's like, we want to make sure that I keep in touch with all the folks that were kind of doing this, let's call it 5 to 10 years ago, because I think it's really important to realize that like a lot of the ideas were correct. It's just that back then and before kind of we started pushing stuff together with putting stuff together with Impulse, there really wasn't a way to have any performance change to the products. You were people went down the like, hey, we can put like Wi-Fi connectivity, we can put a large display, we can do guided recipes, we can do all this stuff, but there wasn't like, the thing didn't work any better as an oven versus like a best in class, like has all the bells and whistle features like Gaggenau, like steam oven or something like that. And so you end up in the situation where for the total power user, you may not convert them because they'll have a better product. Like there's a better product they could get that's like in a known brand. The like people like maybe us that would use kind of the smart guided recipe thing are not necessarily the tastemakers on the, they're not necessarily the tastemakers on like, this is the single best thing. By the way, I'm Gordon Ramsay, so I don't need to follow instructions on a screen. Like it's like that sort of, like that's the sort of situation where it's because there wasn't a fundamental performance enhancement, people went down the smart thing. And I think it's the oven cases, it made sense, but like, I don't need to know that I'm out of Diet Coke in my fridge. Like some of the fridge stuff has gotten ridiculous, the refrigerators, displays and all this other stuff. It's like, we're going down to this thing where it's like, we need to release new products so that there is there's a reason to buy new products, but like, it hasn't converted over into like, there's a genuine advance here.
Yeah. You're saying like there's the value proposition wasn't strong enough for a lot of these, these advancements. And it probably wasn't attracting what you're talking about is like, people who really care about cooking versus people who care more about like the gimmicks and like the, the touchscreens and things like that.
Or convenience. Like I think the really successful ones these days are like straight up, like you get meal kits and it auto cooks them. And like, that's a thing, right? Like it's not a small market, but it's not going to replace, like, I want the best single oven on the market. Like you're not going to be competing with that person.
Is that where your niche is going to be? Like you want to create the best single like pizza oven on the market? Is that, how would you define it?
So the idea here is when we went to like look at, so we talked about doing a pizza oven and I was thinking about doing a pizza oven. Like that was kind of like the first thing I came to with like, if I actually had more power available, what could we build? And, that was kind of the first entry point to thinking about it, but realized that like the big story is like, you got to dethrone the gas stove because people like their gas stoves, and being able to kind of just frankly kick the pants off the gas stove is, I think, required to change people's minds. And that was in some sense the impetus.
Interesting. And what's the model for you? Replacing a stove, like, it's not that easy, right? You got to take out the old one, remove the, put in the new one. It's a relatively big piece of equipment. Is your goal to like install in new homes, or is it to like get people to like upgrade their existing ones? And how do you get them to, overcome that friction? Yeah.
So one thing to keep in mind is like, this is a big market, even with assuming that it's a pain in the butt. So there's like 140 million homes in America, and like, it's like 1 in 10 or 1 in 7 get like their kitchen remodeled in any given year. And then major appliances get replaced at like a 10-year clip too, because like your water heater breaks, your dryer breaks, sort of stuff like that. And so the replacement rate is actually quite big just in like the combo of remodels and regular replacements due to, damage and stuff like that. And then there's like the people who are now concerned about natural gas due to health risks. And there's emerging like people who want to switch. And then the last one is like, there hasn't been a lot of genuine advancements, especially in the performance side. So if we can go and say like, yeah, we have literally the best thing, and it's like 3 times higher performance than anything else in the market, there's also going to be some people who just want to upgrade because this is the thing that's available. And maybe they've had the same stove for 15 years, but like, and it's not broken, but like it might as well do the upgrade because we exist. So part of the idea was like, we have to make sure that there is we overcome the friction. But it's also the competition here is not like there's just been not a ton of innovation in this space for like 50 years. So there's an opportunity to kind of be really distinct though.
It reminds me of when I started Mercury. Everyone was like, "Oh, no one wants to change their bank," and I always said, "Hey, this all the banks suck. They're the same sucky products. So of course, no one wants to change." So I think if you can actually innovate on something, there's a new behavior you can create. But it's definitely like a barrier there. But I guess like you have the additional benefit that's kind of viral, right? Like people will see this in their friends' homes and they'll be like, "Oh, that's cool. Like I want that."
You could boil a liter of water in under 40 seconds. Like the temperature sensor stuff is just like, we're going to be talking more about that soon, but it's like, there's a bunch of things that are like not obvious about how much better this is that like once we start rolling out the content.
I wanted to ask about that actually. Like you mentioned that you can sous vide with this because of the temperature sensor. So
yeah,
I guess how does that even work?
So there's some videos that we posted, but I did this today actually for someone who came by for a demo. You can throw a steak in a pot raw. The pot is empty. Like there's no water in it. And you set the temperature to like 130 Fahrenheit-ish or 55 Celsius. And you just wait and you come back and flip it every maybe 20 minutes or so. It'll be cooked through just like a sous vide machine was, but you don't need the plastic bag. You don't need the water. You don't need any of that other stuff. And then you let it sit and dry out. Follow all the instructions online. I got totally roasted, by the way, for doing this improperly. This is like the thing works, but it was like I didn't actually cook it right. Then you just pan fry it and you get a perfectly cooked steak and it's like crisp edge on both sides, but like the middle is like perfectly medium rare all the way through. Yeah, that just works. And it's like once you get the hang of doing it, it's like super, super easy and very few steps.
Was that an intended use case or did you just like happen to come up on a...
I will give you the kind of storyline here. So we were like, let's make the highest performance stove. The goal here was just to kick the pants off of everything. And so we were like, let's make it like 3 times more powerful than any other induction stove in the market. Let's make it like 5x more powerful than gas. Let's really like accelerate, if that makes any sense. We very quickly realized that there was a sensing problem that one of the reasons you couldn't, there are a couple of reasons why you couldn't do this before. One was the battery. Like you didn't have like, maybe the whole stove could use like 10 kilowatts, but like you couldn't allocate that to an individual burner. So like the battery lets you do that. And then the second piece was there's a control systems problem where like you couldn't keep it safe. You couldn't keep it from like over temperaturing a pot or whatever. We basically realized like we had to innovate on the sensing technology to be able to unlock that performance for people. And once we did that, we realized that not only did we unlock that performance, but like we now have all this control and precision that we didn't have before.
How do you get the word out there? What's your strategy to like actually, do you have to go to like cooking shows? Do you try to partner with Gordon Ramsay? How do you try to get, tell everybody about this amazing Better Mousetrap?
You're catching us at the very beginning of this. I think part of this is like, we're kind of just putting the stake in the ground that we have the highest performing stove on the market, period. Most of the industry players know about us now, which is cool. So we're starting to get that attention from like on the manufacturer side. So there's like interesting partnership inbound that we're seeing, which is cool. We're just starting to get inbound from kind of the like, and like having conversations with like, let's call it like the elite opinion maker type folks. And I think part of the goal here is to build a permission structure to trust a new brand. And that's something that we're kind of piece by piece building. It does kind of start with like being able to piggyback on the kind of the tech enthusiast set of folks that also cook a lot as like an initial beachhead, but definitely not the key decision maker market for the majority of customers. Like you have to get in front of families. You have to show that, hey, you can keep your baby milk at exactly the right temperature with this. Like you have to show all these capabilities that are not just like kind of in your face. Here's like how this is how you make the perfect steak kind of thing. You have to make sure that we can show a wide variety of capabilities. And part of this is like making sure that we're out there just enough so that we can kind of get those partnerships and media tie-ins and all those other stuff started. And so you're catching us at the very beginning where we have a number of these things in flight, but it's like kind of the first step is to kind of poke our head above the waterline, basically.
Sounds good. One of the things it reminded me of was like just the Nest as well, right? Like it's trying to significantly upgrade, something that's been in the home for a long time. And that was something that's worked really well. I think probably Other examples of like things like that, which is significantly better in home appliance, it's just kind of taken over. I guess the Ring doorbell is another one.
Actually, induction stove is kind of the counter example where like people don't even like know what type of stove they have. Like you talk about like regular electric stoves and how terrible they are, and like how a bunch of people get these flat glass rectangles and don't know which, if it's induction or what's called radiant electric, which is like almost like a light bulb that goes underneath the glass. So it's like you end up in the situation where there's been cases where this notably did not work. And I think the tech industry and some of the more recent companies, and we'll use kind of the smart home ones and companies like Nest as an example, is like have done this a lot better in terms of the framing, where it's like, I think fundamentally this is a consumer electronics device, and like being able to kind of ride the tailwinds of that industry, not like, and realize that like this is a consumer electronics device. It's not some like legacy category device, is important to kind of making that sale.
Are you concerned that there'll be a lot of copycats? I feel like with consumer electronics, it doesn't take long for someone in China to do this and undercut you and all of that kind of stuff.
Yeah, so I think it's worth describing what we're doing in completion to make it clear that I don't view that as a giant risk. So the first thing is like, this is kind of in some sense the capability of doing the temperature sensing is not just it's not a simple thing, and like that there's some serious R&D work that is not easily replicable that landed there. A second factor is, just putting a battery in the stove and making the install easier is one thing, but like the big picture here is we are taking over, convincing people to upgrade their appliances to something way better that puts a 3 kilowatt hour battery into their home implicitly per one of these appliances they upgrade to. And the idea is to like just be able to keep cranking out category leading hits. Those batteries network within the home and form like essentially the idea is to tie all those batteries to the grid. Then it's kind of like we are then running a giant global distributed storage network of batteries. So but then it starts with this wedge of like, hey, you're going to want to upgrade your stove to this thing. And if you then slice this product wise, even if the stove is something that kind of has competition, all of these additional things are like just so outside the core business of any of the companies that would be in a position to replicate this, that it's like, I don't see that as a concern.
So is the idea that like my stove is now fully charged? Let's say you live in Berkeley and they decide to switch off your electricity or something. At that point, will I be able to charge my phone from my normal plug because the stove is pushing power back into the home?
So we're not launching with explicit backup capability. So like with the stove able to like power your house when the power's out. To do backup, you need to have like a switch to disconnect your house from the grid. We can cooperate with other systems, but the idea is we're not starting with that until we have multiple appliances. What you can do though is like when you're tied to the grid, we're able to basically support the grid with the battery. So it's not just a stove that like can run when the stove can run itself when the power's out, by the way. So like if the power goes out, you're able to cook for 3 meals. But the other piece is basically that we've deployed a reasonably large battery, and that is then able to like offset your home electricity during those peak hours that are more expensive. And so the savings can end up being in parts of California, depending on your rate plan, you can end up saving hundreds of dollars a year just with that battery.
Okay, can you explain that a little bit more? Like, how does it know this is a cheap time versus an expensive time, and how does it like push the power into?
So those are two different questions. So the first one is, in many states, there's what's called time of use energy rate. So it's like pretty much a standard schedule, and so you would just select your rate plan, and then it does it basically. So it's like it will just choose to charge the battery at like any time that isn't 4 to 9 p.m. or something like that. This is like the simple way to think of it. And then you'll literally save like you'll save 10, 20, 30 cents, 10 or 20 cents a kilowatt hour if you charge the battery outside that window. And then the second thing is when you're in that window, it's usually when you're cooking dinner. So like you essentially will be able to cook with energy that was bought for more cheaply than it currently is at that time. The second piece is, the product has an inverter in it. And so an inverter converts DC to AC. And so this is the same sort of technology that's in, like, if you get solar panels on your roof, it's the same thing that's inside the Tesla Powerwall. But basically it lets you turn the battery energy into grid energy effectively. And so that's able to, the idea is basically battery energy that you're not using to cook your meals, you could push into your house to run other appliances or your laptop or whatever, to, instead of grabbing new energy from the grid at that time that would be more expensive. So you can actually use it as like almost like an energy trading desk kind of thing.
But the customer is like making some decision to go like, hey, now switch to inverter, or are you automatically doing that?
It's automatically. Yeah. The idea is it's like you just go on a schedule and it just works on a schedule. And this is,
okay.
You can see this in like
you
the
tell
Tesla
it
app.
like, hey, I live in California, lunchtime, we got tons of solar power, suck energy then, evening time, push energy at this point, and it will just do that from then on.
It's even simpler. It's like selecting the leaf button on your Nest, and then we figure out what your rate plan is. We figure out a bunch of other things, and then boom, it just works automatically.
Oh, that's super cool.
And you don't notice. And the goal is you don't notice or have to really micromanage this. You'll always have enough energy to cook.
Got it. And like let's just say California. I mean, maybe San Francisco, since we live here. Like, how much, and let's say reasonable usage pattern. Like, how much electricity money do you think this would save?
Yeah, so it depends on the rate plan. There's some really aggressive time of use plans that PG&E just rolled out. I think it's on the order of like the plans like a year or two ago were more like $70 savings a year, which is not a crazy amount, but it's still like somewhat for a battery this size. It's now like, I think in the many hundreds, like 200 plus, if you're on some of these like more battery favoring plans. I know in Southern California, it's been stark like this for even like at least the 2 years I've been paying attention to this, where it's like you can save like $250 to $300 on a 3 kilowatt hour battery, which is pretty crazy. So there's actually really big opportunity here just to lessen the price of the product, basically effective price of the product, basically.
Yeah. And so you're kind of imagining that there'll be like 3 or 4 of these products in someone's house. There'll be like a stovetop, a microwave, a dryer or something. And then at that point, maybe you'll have not a power wall, but like some sort of switch thing that you insert in the kind of central point of the house. And then now you've got this distributed battery in your house, and then you can charge it. Maybe you can even have a solar panel and like all of that kind of stuff.
Yeah, you could imagine that like instead of having a centralized battery like a power wall, you install piece by piece like 3 or 4 major appliances, and we'll pick out all the ones that kind of are high peak load. So like you could think of like hot water heater, dryer, those oven when you preheat it, like those are all kind of logical ones that are not just stovetop. So you do all that, and then the idea would be there's a little bit of plumbing you got to do at the front of the house basically to, if you want to actually use it as a backup source. If you, in the case where you don't, it doesn't really matter, right? But because the individual appliances will still work when the power's out. But the idea is, like there will be some additional plumbing once we have the ecosystem to kind of enable those sort of features. But that's in the future.
I just looked it up, and a Tesla Powerwall is 13.5 kilowatt hours. So you basically need 4.
It's 4.
4 of those. Okay, that's cool. That's a cool vision.
One question: I already have a battery, like I think an Enphase battery or something, Franklin battery. To power my for a backup battery to power the house if there's a power cut, which there was this past weekend. Do I need a second battery for your appliances, for example, or can it work off the same battery?
The battery is built into the appliance, so it's literally like in the case of the appliance there's a battery, and this would add to any grid tied storage in your house. So like if you've got that battery, like the idea is that we won't play mean with it, we'll play nice with it, but and so it's like frankly additive to whatever you might already have. The difference is like the appliance itself runs directly off the battery voltage. So it's like the appliance gets a super high power DC connection to the battery that is co-located inside it. And what this means is, unlike if you get an induction stove in San Francisco, you probably have a gas stove and you're probably going to have to get like an electrician to come and run a 240 volt line from your panel to your kitchen or something like that. The issue with that is that's like expensive. But then the second issue is, in San Francisco, like you likely don't have a 200 amp panel. Like you likely don't have 60 amps available for you to go do that. You end up in this pretty bad situation where it's basically you may have to call PG&E and wait 18 months for your utility to come by and run new wires to your house that are thicker. And I have neighbors that are in that situation right now where it's basically like their remodel effectively has been on hold for like over a year because of they've been basically waiting for this to happen. And so when you integrate a battery into the appliance, it's not just like you're making the appliance more performant because you've got that local battery, but you're also solving this install barrier that's like normally needing a 60 amp 240 connection. You now could use a 120 volt 15 amp connection or a 240 volt 10 amp connection. So it's a huge deal for unlocking that install. And then let's say you install this on 240, it will be additive to your home battery system. So it'll add 3 kilowatt hours, kind of like your total home amount of storage.
Was there a recent kind of improvement in batteries that's really enabling you? I heard batteries are not improving that fast, or is that not the case that they are?
We're actually back. So there's two or three things that have happened. One is cost is down enough that this like makes sense. So like we're now at like, I think under $100 a kilowatt hour for batteries. And that's like, if you're Tesla and negotiating hard, like that's what you'll pay. If you're a startup, it's not gonna be that cheap, but it's way cheaper than it was before. So it's like actually doable. The second thing is lithium iron phosphate is like ascending as the dominant chemistry in a lot of use cases, especially for stationary battery storage. And this is important because a lot of times people are worried about battery fires. They're worried about like basically like batteries catching on fire. They're worried about the cost. They're worried about various other things. For stationary batteries, you also don't care about the weight. So lithium iron phosphate is like a lower energy density chemistry. It weighs more, but it doesn't actually, it has way better fire risk characteristics. Like it doesn't supply its own oxygen to burn. So you can get it approved for indoor installation way more easily than a packed. Lithium iron phosphate is not new as a chemistry. Like A123 Systems, it's like an MIT spin out startup, came up with or really pioneered this technology in like the 2000s. They ended up getting bought by, I forget exactly how the exact sequencing happened, but almost entire market is now in China. And a lot of these Chinese EV companies and battery companies have basically spun up huge factories building lithium iron phosphate, LFP batteries, and push the cost really, really, really aggressively low, which is now enabling all of stuff like this, basically.
Oh, that's interesting. Where else do I see lithium iron phosphate batteries?
If you get the cheap Model 3, it has lithium iron phosphate batteries in it.
Oh, really? Interesting. I guess talking a bit about manufacturing, you're not manufacturing this yourself. Like, can you give us this is your first startup though, right?
Yeah, it's my first startup.
Right.
But yeah, I've done many consumer hardware programs before, so I can comment kind of on how the big folks do it as well. But let me start.
Yeah, I'd love to know, I think there's a lot of people listening probably that are software entrepreneurs like ourselves. And like, how do you go about making a consumer electronics device?
Yeah, so I think the philosophy is like, and this is actually where I think there's maybe an ideological split between kind of the, I would say the ex-SpaceX people and like the, let's call it ex-consumer electronics people on how to do stuff. And I'll start with the SpaceX side because I think Elon talks his book a lot, and like I think it's pretty good in terms of understanding why that exists. So like SpaceX has prided themselves in vertical integration. They've prided themselves in like, hey, like we'll do it in house. We'll make sure it's cheap. We'll reduce what's called the so-called idiot index, which is like the cost of goods, the cost of the item divided by the cost of its raw materials. And in the aerospace industry, when people were making one of Lockheed Martin orders 5 of something, the prices are pretty insane and like super expensive. So being able to push back on that and actually be able to build rockets for cheap is a huge, huge, huge deal. And then the second thing is because the volumes are so low, the supply chain and like suppliers who quote unquote are like industry standard and are known to do stuff aren't necessarily going to like give you good reliability and high volume. And so that's where like you get a lot of this, especially in the kind of deep tech startup ecosystem. People are like, well, we should just like look at SpaceX as like the gold standard here. Now, I gave you kind of the situation and the environment for why SpaceX made those choices. A lot of those choices are different in consumer electronics and different in consumer devices. And so a big deal is like, and the other part is like, you can't go and like rent a rocket factory. It's probably the right way to put it. But you can go talk to a Foxconn and they can build you something that's 95% of an iPhone or something like that. Like it may run Android, but you get the idea, right? So like the maturity of the consumer electronics supply chain is just so much vastly bigger and better. And so you're in a spot where being able to leverage what already exists is it's almost like a must do, not a should do kind of thing.
Yeah. So roughly you're saying if it's low volume, extremely custom, maybe you do it yourself, build your factory, be vertically integrated. If it's high volume, I guess pieces of this are custom, but they're similar products, right? Then you leverage what exists. And then I guess like this is the big advantage of China. Like they already have all these factories, they're all next to each other. You can presumably get most of this assembled there.
There's a second piece to this too, which is like the capital efficiency of doing stuff where your main manufacturer actually has the design engineers staffed for you to actually go and iterate on the product. So it's not just you get a room with some operators and they build it, and maybe you get some people who know how to do the supply chain and ordering and can figure out like where to find the special parts and stuff like that. It's like, no, you also just get like 20 to 40 engineers working on your program, like as their sole thing, and they basically work for you. And then that lets you basically not just so when you prototype stuff in, say, your lab in San Francisco, you will then have to find vendors and suppliers that make all of those individual widgets like within the supply chain near where your factory is. But if you do that initial development work with the factory themselves, they will use the vendors that are already in their network as part of the design process, which means that the switch from like, hey, I want to scale volume is not like some painful one. It's like not instant, but it's a like you can ramp to higher volumes without changing the architecture of the product, basically.
Would you say there's like a minimum amount of money you need to raise if you're going to go do this and like work with the factory? Is like, no?
It's probably proportional to how complex your program is. I think a lot of it's like you just have to convince them that you know what you're doing and know how to do all stuff. This is not like absurdly expensive. It's very capital efficient, effectively.
But like if you're just out of college with no money, like that seems it's presumably not.
Yeah, yeah. So I think a big part of this is like you have to know how to kind of do the interpersonal networking required to kind of build. Like there's a lot of like trust and like making sure you have a track record and making sure they think you're worth taking a bet on. Because effectively it's like it's not exactly the same as pitching investors, but it's in the same sort of like vein of like what that experience is to a certain degree, because they are they're spending opportunity cost on taking your program, basically. Like they're assigning like tens of people on their team that could be working on like trying to win a bid for like, let's call it like Apple's making the next Vision Pro or something like that. They could be assigning those to your startup. Now, partially that means like when you're a startup, you're not going to be able to go play ball with Foxconn's like A team your first go around, but like you get the picture. Like they could be working on other things, and so you have to be wise on how to pitch it, basically, even though you're paying them.
Yeah, that sounds very familiar to me, Sam. Journeys that I've had to go through in the past making hardware products. I guess one question I have for you is just like, how do you see the future of smart appliances and like the home? How do you see, what other big opportunities do you see are out there? Or, what's going to change 10 years from now in our homes?
Yeah, I think the inversion here is like people talk about what we're doing and like think about it like in a smart appliance sort of way. And it's like, I think there was kind of a solution looking for a problem in this space for quite some time. What I think the big deal is, and I think Nest hit the nail on the head here, is like energy is a big story. Like energy is a big story. This is going to be the forefront of everything very soon. And if you can basically own the home energy story, it's a justification for the thing having Wi-Fi more than like recipe integration or something like that, if it makes any sense. This is where the kind of connectivity arguments that people were making in like the late 2000s, early 2010s around like, oh, we can put a mobile class chip and everything. That was not, it was again a solution looking for a problem until a lot of these like new energy, the new energy stuff really landed and became obvious for everyone.
So I mean, what do you think so you think like the biggest changes in the next 10 years are going to be around energy storage and usage?
It's not just for appliances, but for like your car, for all these other things. Like the integrations around energy storage will be like in some sense, taking the brain slot of like the smart appliance thing, and are going to be broadly more useful and more impactful than like your fridge telling you you're out of apples, if that makes any sense. I also think that there's going to be innovations in HVAC across the board. So we're going to start seeing like people getting rid of their gas heat and getting heat pumps at like increasing scale. It's already subsidized, so it's like it's going to start happening in increasing scale as people's like stuff fails. They're just going to replace it with something crazy efficient. What that's going to, I think there's going to be opportunities for new surfaces there as well, for like individual room climate control, for like there's going to be a number of different things that could happen in the next 10 years or so there as well. And then lastly, like the EV charger situation is going to put pressure on home electricity. So like if everyone in SF gets an EV charger for their garage, we'll run into this problem of like there will be a shortage of transformers on the street. Like we'll have to like, this is also going to be directly at odds with everyone getting rid of their gas stoves, which they also want us to do. So it's like, there's going to be kind of this like pressure crunch on electricity infrastructure that's going to happen at the back half of this decade because of just everything going electric, especially vehicles.
Do you see a place for robots in our houses, or you think that's way further?
I mean, I think the robot stuff is going to get interesting, where it's like you're going to be able to do robots way more easily because like essentially the software is going to unlock cheaper and cheaper robots. The other thing is like, again, these manufacturers for consumer electronics, a lot of them are starting to make like compact, like leg and arm actuators. Like this stuff is starting to get scale and get cheap. Like it used to be like, hey, I want to build a humanoid robot. You can build a crappy one for like hundreds of thousands of dollars. Now it's like you can go on AliExpress and find like motors derived from like MIT Cheetah that are like pretty dang good, and like go and build like it's kind of like where drones were in like 2008 or something like that. It's probably the way to like quadcopter drones were like in 2008, but we're like at the cusp of like a ton of just like explosion in this sort of space. What it's going to mean is like the equivalent of like the DJI Mavic's going to happen, that like you can get like a humanoid robot that'll follow you around and stuff like that. We're not very far off to like that being purchasable in the like thousands of dollar price point. The question is like, I don't know what the use cases are going to be.
Why don't you put an arm on your stove, and then, you know, when you're doing the sous vide, you don't have to flip it. It just the arm flips it.
I think we'll spend our software resources on building the biggest aggregated battery before we spend it on.
You let someone else do it now. Who knows? You got to think big, Sam.
Because I think that's the big picture here. Is like we want to basically combine all the batteries that we deploy through the best products we can make into essentially remake the power grid, with us essentially being the broker for electrons. And I think that, and if you think of the order of magnitude here, it's like, this sounds a little bananas, but it's like if 10% of all appliances are replaced in a given year, and you put a 3 kilowatt hour battery in each one, maybe you do 3 or 4 appliances that you said, this is like 140 gigawatt hours a year of storage deployment. What is currently deployed on the US grid is like 60, maybe. I forget. I get different numbers on this, but it's like, it is multiplicatively more than what is currently deployed. And so this ends up being a like big story where like the grid could be like super intermittent and like mostly solar and wind. And like this sort of scale of batteries would mean that you wouldn't notice. It's that size basically.
It was great meeting you, Sam, and I really enjoyed this conversation. Yeah, I'm very excited about what you're building. It's super cool.
Great meeting you. Yeah.
Wow, that was a really fun recording. I really liked Sam's energy. I'm excited about the appliance for sure. You know, it's rare to see Silicon Valley entrepreneurs go after hardware in general, but actually even rarer to see them go after appliances. Yeah, I guess, why do you think that is, Raj? And do you think like the problems that are obvious in these kind of things are going to be overcome by impulse?
Yeah, it is very rare, and it's rare because it's so difficult, and it's difficult for many reasons. You know, I've obviously built hardware in the past. It's been most of my career has been building some type of hardware.
Yeah, what is the hardest part of building hardware?
I mean, the hardest part is running out of money. I mean, you know, you can, it's
Like because of inventory and stuff like that?
Yeah. Inventory risk is huge. It's killed many companies, and in fact, you could argue that the only hardware company that's managed to be like truly independent has been Apple, right? So like, there's no, everyone else, even Tesla we talked about, Tesla today, right? And so, and Tesla went through many near-death moments before it eventually succeeded, right? It was touch and go for many, many years, and Elon Musk is like a once in a generation entrepreneur. So it's not easy. Let's put it that way. And he's built something better. You can tell he's very confident about that, but he hasn't come into some of the business realities yet. And so, that's going to, hit him over the head at some point, and it hits everyone over the head. So you can't go into that, not being super optimistic, because if you aren't, you're not going to even start. Right. So many smart home companies, they end up selling, then they end up having to find someone with more resources because there's no other way to do it. Ring sold, right? All these companies sold. And this is what he's doing is way more capital intensive than like a Ring or even a Nest. So you just need a lot of capital. And I think that's the biggest challenge. And then with hardware, anything can go wrong too. So you can ship some product and it has a problem, right? And then you don't know about the problem until like 2 years in, right? That happened to us, right? And it happens to every company, actually. Even Tesla. Tesla does like recalls all the time. So it's just hard to know until you ship the product that you have problems. And that hits your financials even more. So you got the double whammy of inventory and then products breaking.
I think that one thing that helps Impulse is it has that climate tech energy story. There's a lot of money going after climate tech right now, which is, I think, a good thing. There's like several funds with billions of dollars that are just committed to this. So to some extent, this inventory problem is like a cold start problem, right? Like it's like getting to like a stable enough level and having the capital to get there. So I think if he can keep that story tight, then maybe he can like raise enough money to get past it.
That's going to be the key for him, just raising a ton of money.
You said you've got battery in your house. How much kilowatt hour does that do?
It's actually very similar to the Tesla Powerwall. It's a basic competitor to that called Franklin. And I got two of them. So I've got like 27 kilowatt hours. Yeah.
Is it expensive?
It's about $40K for both batteries combined, so $200K each.
So you do you think like if you bought, I guess you'd have to buy 8 of these. So maybe if you bought one of your walls and like 3 or 4 appliances, like would you see that as like a trade-off in your head that like, oh, I already have the battery capacity? I guess they're not there yet, but that'll be kind of interesting. I wonder, like, is that a model that people would have in their head?
Look, I think every house should have solar and battery powered. I mean, it's in California, it's like crazy to not have it. Like it's cleaner. B, it's like it protects your home in a power outage. Then if you're running like an EV, which many cars are moving to EV or hybrid, it becomes even more important to have solar and battery. So, and then I think that battery could be the center point or like the hub for all these other appliances as well for bigger power needs. It makes a ton of sense. It doesn't make sense to have like a ton of batteries in your house, right? So you want to run it off the same core set of batteries.
Yeah, I guess that's like an interesting counter that like maybe should be centralized rather than like distributed. But yeah, all right. So pretty interesting conversation, exciting product. Let's see how they develop.
Yeah, excited for him. And I think, he has the ability to tell the story, and, his enthusiasm is going to win over a lot of people. So I'm very excited for that. He's going to do well. All the best to him. And that concludes our show today on the Curiosity Podcast. Listen or subscribe on YouTube, Spotify, Substack, and Apple Podcasts. I believe I got all of them. All right. Thank you, everyone.
Thanks, everyone. Bye.